Hello everyone. This video will serve as a refresher course in preparation for your midterm exam. This video will cover the following topics: variable separable, homogeneous differential equation, exact differential equation, first order linear differential equation, and Bernoulli's equation. Let's begin with the method of separation of variables. Let's consider this example. Obtain the general solution of the differential equation dx is equals to t times 1 plus t squared times secant squared x dt. To apply the method of separation of variable, so first thing to do is we have to apply some algebra manipulation to separate the variables. So from the problem, we have, let's rewrite the equation dx is equals to t times 1 plus t squared times secant squared x dt. Okay, so let's perform some algebra manipulation in order for us to separate the variable. So we divide dx by, we have secant squared x, then on the other side we have to divide it also by secant squared x. So the resulting equation will be, we have dx over secant squared x equals to t times 1 plus t squared dt. Then we can also rewrite dx over secant squared x to, we have secant squared x is the same as, we have cosine squared x dx is equals to t times 1 plus t squared times dt. Then we cannot directly integrate cosine squared x dx. To integrate cosine squared x dx, we still have to rewrite it into much simpler form by applying the double angle identity. We have for cosine 2x, cosine 2x is equivalent to cosine squared x minus sine squared x, and it can also be written as, so sine squared is the same as 1 minus cosine squared x. So then we simplify, we have 2 cosine squared x minus 1. So we have cosine 2x is equals to 2 cosine squared x minus 1. And also, cosine squared x is equals to, so we transpose negative 1 on the left side of the equation, then we divide it by 2. So we have cosine 2x plus 1 over 2. So cosine squared x dx is the same as, we have cosine squared, cosine 2x plus 1 over 2, then equals to t times 1 plus t squared dt. Okay, then after that we can now apply integration. So we have integrating both sides. So we have for cosine 2x plus 1 over 2. So we can just move the constant term out of the integral sign. So we have the integral of cosine 2x plus 1 dx. So let's let's prioritize first this the left side of the equation. So the integral of cosine 2x is we have 1/2 sine of 2x. Then the integral of 1 is x. Then next is we integrate the right side of the equation. We have the integral of t plus 1 plus t squared dt. So to integrate this expression, so we just have to apply the u substitution. So we let u equals to we have 1 plus t squared, so that we have du is equals to 2t dt. Then du is equals to 2t dt can also be written as we have 1/2 du t dt. Okay, then we substitute it. So we have the integral of t dt is 1/2 du. So we have 1/2 here. Then we have du. Then 1 plus t squared is u. So we have u. Then we can just apply the power formula here. So we have 1/2. So the integral of u du is we have u squared over 2 plus the constant term. So and then we put it back to its t variable. So we have 1/2 times we have u is 1 plus t squared. So we have 1 plus t squared raised to 2 over 2 plus c. Then let's now simplify this equation. So we can just cancel out 1/2 here. Then we cross multiply 2, or we multiply both sides by 2, so that the result would be sine 2x. So we have 2 times x is 2x. So plus 2x equals to 1 plus t squared raised to 2 plus c. So this will be the final answer. So let's proceed with the next example. So we have obtained the general solution of the differential equation 1 plus ln of x dx plus 1 plus ln of y dy is equal to 0. So as you can notice, the variables are already grouped together. So we can just we can directly proceed on the integration part. But before that, we just have to distribute the terms. So we have 1 times dx is dx. Then we have ln of x times dx is ln of x dx. Then we have plus 1 times dy, we have dy plus ln of y dy, ln of y dy equals to 0. Then we apply integration. Okay, so the integral of dx is just x. Then to integrate ln of x dx, so we don't have a direct formula to integrate ln of x, but we can apply the integration by parts. So we let u equals to ln of x, then the derivative of ln of x is 1 over x. Then for our dv, we have dx only. The derivative of ln of x is 1 over x dx. Okay, so then dv is dx, then v is, so the integral of dx is x. Okay, so same thing will be applied with ln of y. So then we apply the integration by parts. So we have our u here is ln of x, then v is x. So we have x ln of x, then minus the integral of v du. So we have v is x, then u is 1 over x dx. Okay, then the integral of dy is, we have y, then plus the integral of ln of y dy, same thing with ln of x. So we have y ln of y minus the integral of y times 1 over y dy. Then let's put the constant term on the right side of the equation, and then let's simplify this equation. We have x plus x ln of x. So we have x times 1 over x is 1. So we have the integral of dx, then plus y plus y ln of y minus, so we have the integral y times 1 over y is 1. So we have the integral of dy equals to 0. So then x plus x ln of x, so the integral of dx is, we have a negative x plus y plus y ln of y. So the integral of dy is y only. So we have negative y. Should be c. So c. So we have x minus x, so we have this one will cancel out, then also with y. So the result will be x ln of x plus y ln of y equals to c. So this will be the final answer.